This call is being recorded.
Hello, everyone, and thank you for joining us. I am Andrew Halloran, Director of Product Management at OptumSoft, and I'll be hosting and moderating today's webcast titled Making HVAC Smart. Smart HVAC leverages modern Internet of Things technology to bring intelligence to industrial and commercial applications. Today's webcast is presented by Denis Vilfort, Chief Marketing Officer at OptumSoft. Welcome to the call, Denis.
Hey, thanks, Andrew. Really glad to be here.
So, Denis, you've been in IT for what, 30 plus years now?
Yeah, it's hard to believe, but yeah, I've seen a little bit of everything. I started back in the day with the IBM PC. That was a hot thing back then. Hard to remember, but yeah. So now, of course, the big thing everybody's talking about now is that all this cloud technology and Internet of Things, that's actually becoming the hot topic. Yet very few people fully understand how they can actually move forward with IoT. And that's what we're going to talk about today.
Perfect. So we'll get this webcast kicked off in a few seconds here. Just a note to all our viewers out there, if you have a question during the webcast, just please use the chat window and I'll address your questions at the end. So I'll hand it over to you now, Denis. Take it away.
Thank you, Andrew. Appreciate it. This is an exciting time for the industry. And we're basically, everybody's talking about Internet of everything, Internet of Things. Yet a lot of people, frankly, are struggling a bit with finding out how it's actually being applied to their business. And today we're going to talk about how we apply Internet of Things technology specifically to HVAC. But it's not limited to that. It actually goes across everything. But here we're trying to drive a focus on heating, ventilation, and air conditioning. Now, to take a look at this in a more historic fashion, you actually could begin to see that this is a pattern that has been going on for a while. Ever since computing started with big, expensive mainframes in the 50s and 60s, in those days, very few people were sort of part of an inner priesthood that understood computing, and you had to go to MIT and whatnot to figure all this stuff out. But then what happened, thanks to what people refer to as Moore's Law, which is basically that every 18 months, the amount of transistors you can put in a particular space of silicon wafer doubles. And that, since it costs the same amount of money to actually build that chip, the packaging and so forth, it actually turns out that it also means that things get cheaper. It actually gets cut in half in terms of production cost for the same amount of performance every 18 months. Now, 18 months can be a little difficult to sort of use for planning purposes, but if you actually look at 18 months over 5 years, then you realize, oh, there's actually a 10 doubling every 5 years. And we've seen this over the history of computing, that we went from the 50s, 60s, 70s, right? Personal computers came in the 80s. Then lately we got, like 10 years ago, we had the smartphone. What was this really an indication of? Well, things got more and more powerful. And as things got more and more powerful, they can also become smaller. Because if you don't need a lot of firepower, but you want to take computing on the go, you could argue that a modern smartphone was actually the Walkman of computers. It's basically the ability for you to have a supercomputer in the palm of your hand. So you can do phones, you can look up the internet, you can do all the things that Steve Jobs mentioned 10 years ago. And that's actually interesting to notice, because 10 years ago, if you look at, like I said, a tenfold increase every 5 years, that means the iPhone you get today, or the Android phone for that matter that you get today, is actually 100 times, because it's two times 5, right? So we had 5 years, that's 10x, another 5 years, that's another 10x. Those two things multiplied together means that the phone you buy today for the same $500 you spent maybe 10 years ago is actually 100 times more powerful. But what if we don't need more power, as I just mentioned? What if we actually want to make things smaller? And that's the other aspect of this. The Internet of Things are now just taking off as the smartphone trend is maturing. That's why a lot of people are talking about it. And some of the analysts are saying, hey, just in 3 years, we'll have 50 billion devices connected to the internet. And it'll be anything from toasters to machines to pumps to all kinds of stuff is going to be made intelligent. But the funny part is there's a lot of stuff out there that isn't intelligent. And that's the opportunity we have before us. We can take intelligence and put it where it has never been before. And speaking of never been before, that was the first time I was on the roof. It was actually 7 o'clock, December 8th, on a cold, windy California day. And as you can see from the pictures here, the roof was rather slippery. We had to watch ourselves. There's actually ice on part of the roof. It's been very cold during the night. Everything was wet, cold, clammy, not a lot of fun. And the team was up there installing this intelligence device. You can sort of see here. This little thing here is actually the computer that's attached to the side of a old, battle-hardened HVAC unit. And as I was standing on that roof that morning, I looked around and said to myself, wow, I see a lot of HVAC systems. If you've been in the HVAC business, this is not new to you. But since I was new to this whole thing, this is the first time I actually had seen that. So talking about a new thing, I certainly got a new perspective. And as I looked left and right, I realized, wait a minute, I've learned from people in the industry that roughly 2 out of 3 of these systems are not running optimally. 2 out of 3 of every unit on the roof. And at that moment, I looked around and said, holy cow, there are a lot of systems on this roof, and there are a lot of opportunity here to save electricity. Because if they're not running efficiently, they're actually burning electricity. We have seen systems that are running during the night when there's no one in the building. We have seen systems shutting off in the middle of the day when there are people in the system, only because, hey, it hasn't been set up optimally. So when you look at that, having a system run for 8 hours a night, all eating a lot of electricity every day of the year, only because of, let's say, human failure, that's actually a problem. And it turns out a lot of these systems are actually in none of the best of shape either, right? So there are compressors that are running below spec. They have fans that are not running, bearings giving out, all this kind of stuff. So I looked across all these roofs and I said to myself, wow, there's an opportunity to do something great for mankind here by making sure every single system on every single roof is completely top-tuned. Well, it turned out, though, that to figure out how big, because I went away from there that morning going, I wonder how big this problem is. So as a good marketing guy, of course, did a little research and finding out that since 1990, we have roughly doubled our power consumption on the planet. So that's just a doubling in just 15 years. That's actually quite amazing, okay? Because so when you look at this, you can see this curve here, funny enough, I want to point out a few interesting things. It has shown a very straight progression, very predictable progression, as you can see, right? Going straight here. There was only around here, we saw a dip. And when did we saw that dip? We saw that during the recession. The big recession we had 2000, 2009, then it dropped a little bit. And then after we came out of the recession, it just continued to grow. So that was the power consumption in the whole world. That's a big macro number. So I started going, we need to find out a way so you can cut this down a little bit. So I needed to build the model. And the model, I asked a lot of people, they said, well, wait a minute, HVAC and refrigeration is actually only 17% of the global consumption. And if you look at that, there's actually a half of that is commercial. The other half is actually residential. Well, I wasn't focusing on residential, so half of that got out of the model. And then smaller buildings are actually 85% of this. Well, we also are not going to focus on big buildings. Why? Because big buildings have automation systems built in already that handles much of this intelligence we're talking about. In other words, this is not a new problem. This problem has been around for a while and been addressed in very expensive new skyscrapers. They all have building automation systems, but 85% of everything out there is actually not a big skyscraper. It's a small strip mall where Joe's Bar and Grill has a nice restaurant, and that thing that they cannot afford these expensive building automation systems. Now, if I then said, well, the guys that are running great, they're not the problem. The guys that are running poorly, in other words, 2/3, that's the next thing. That's why we multiply by 66%. And then finally, well, how much of that is going to wasted energy? And based on Department of Energy and other industry analysts that we spoke with, we landed on a number of roughly 40%. The reason I'm going through this is I'm basically trying to explain to you how a big problem can be cut down to a specific problem. If you looked at all that, multiplied all that together, you can imagine we ended up with a number that wasn't particularly big. It was actually 1.9%. You go, oh, so 1.9%, that is the problem. Yes, but if we actually take that and then look at the average cost worldwide, in Australia, it's horrendous expensive electricity. Saudi Arabia is quite on the other end. But if we take the rough average here between like Germany, Japan, France, South Africa, the whole bit, we're finding that the average kilowatt cost is actually 23 cents. So now we can take the kilowatt spent, multiply them by the number that our model kicked out, and then find out, hey, you know what? What does this mean in actual dollars and cents? And as it turned out, if we fix this problem together, if we use IoT to fix these suboptimally poorly running systems for small and mid-sized businesses, we're talking globally a $90 billion problem. This gave me pause, and I'm sure it gives you pause. And you go, that's such a big number. I can't figure out how to translate that into something meaningful. But let me just give you an idea. This is enough money that we can buy everyone on the planet a medium latte 4 times a year. Now, I'm sure that people in the developing countries are not necessarily standing in line to get a nice latte, but what we can do for the environment is the equivalent of getting 30 million cars off the road. So this is a big impact. We can help our environment. We can save electricity. We can save money, free up money, if you will, so that it goes to more useful things than just spending extra electricity for systems that are not running well. So we felt when we looked at that, we're going, that's actually worth doing. So let's take a step back. Why is it that the HVAC community is actually not doing a phenomenal job at keeping these systems? Why is it 2/3 of the systems are not running well? Well, first of all, it turns out that the Department of Energy estimates that roughly 60% of all systems are just being run till they break. In other words, no one is doing preventive maintenance. But even if we are doing preventive maintenance, it means we're typically sending a good, very skillful technician on the roof because he is a very expensive resource. He can only afford to be on that roof looking at that unit for 10 minutes, 4 times a year. And then we all know, of course, that he has to go up there and maintain things like cleaning the coils, all that stuff, right? Gives visual inspection. So we have to have someone on the roof to do this. But he brings his gauges and everything up there anyway, right? Wouldn't it be great if we can separate the person from his gauges? In other words, wouldn't it be great if we can actually put intelligence on the roof so that we can sever the connection between a human being having all the tools in his truck, having to drive out there. Instead, we actually put a computer on there to monitor the system 24/7. If we do that, what kind of stuff can we find out? And it turns out we can actually begin to solve this $90 billion problem by finding problems very early on, which translates into savings all across the board. So let's talk a little bit about that. What is it we install, you might ask? Well, it turns out this is a universal intelligence kit. What it really is a weather-hardened, battle-hardened computer with a Wi-Fi connectivity that then shares, actually through, not to get too technical, but through a hotspot shared modem talks to the cloud. So there are 2 pieces to this. There is a data collection unit, that's what you're looking at there, with a bunch of sensors attached to it. And as you can see, there are many unused ports on this system. We can actually expand this to several hundred sensors. But here's a starter kit that basically has a couple of useful things for purpose of HVAC monitoring. First, we monitor the supply air temperature. We monitor the return air temperature. We have 2 CT clamps or amp meters essentially that snap around the wires, totally non-invasive. You don't have to cut anything or splice in wiring or anything. You just snap these little donuts here around the wire itself, and we can see what the blower motor is consuming. We can see what the compressor is consuming. Finally, there's that little green thing here at the bottom. Let me show you that right here. That little guy is the filter differential pressure sensor. And it's actually a nice little piece of electronic that will measure the pressure across the filter. So we can see if a filter is dirty, obstructing the actual, the whole airflow through the system. The good news about this system is made for easy install, and a couple of hundred examples of this. We're actually well into several pilots for several big companies, and we've seen that a trained technician can get this down to 30 minutes. That's an important point because that means that a technician can have this kit in his truck, and next time he goes to Joe's Bar and Grill to hose down the coil, he can actually just stay there for an extra 30 minutes and install this. And from that moment on, that system has now become intelligent. That system has now become smart. So if you're a technician and listening to this call, you're probably saying, well, that's lovely. How do I install it? So this specific kit has been targeted at a rooftop unit, in which you see package units all over the place. and they tend to look at the drawing we have here. There's a compressor, filter, heater, evaporator. There's a blower motor, and finally the blower itself. And then there's the ductwork, which is those little white arrows at the bottom. Now, if you look at this from purpose of deployment, you take this data collection unit and you first wire up the temperature sensors. As I mentioned, we actually look at return air temperature. We look at supply air temperature. And so we can see what the unit is doing to the air from the building and to the building. In addition, we also want to see how the compressor is doing, because that eats a lot of power, obviously, when we are in cooling mode, and also the blower, which works both in heating and cooling mode. You can see right here that if we, out of those 4 sensors, right, you can see right here, if we see that the compressor is not running, but we see that the blower is running, and we see that supply air temperature is increasing, we're in heating mode. If we see the compressor cooling, or compressor running, sorry, and the blower running, and we see that the supply air temperature is declining, we're in cooling mode. So we actually can see a lot just from 4 sensors. But as I mentioned, there's that 5th sensor, which is the filter differential pressure sensor, which is 2 plastic tubes that are basically deployed on either side of the filter. And if the filter then starts gumming up by air particles, pollen, and whatnot, we can begin to see that the air going through the filter is actually declining. And if that happens, well, obviously it's time to send someone out to replace the filter. That's a big difference from the way it's being done today. The way it's being done today is we go out 4 times a year anyway, right? If you're in the HVAC business, in HVAC maintenance business, you go out 4 times a year, replace the filter whether it needs to or not. So what this does is it gives you eyes and ears on the system, so you can take corrective action when the system needs it, not when you just have a timed schedule. And all things being equal, that's actually a more effective thing. The Department of Energy basically has estimated that doing things on a needs basis by the way of sensors is actually twice as cost effective overall in terms of maintenance than just going out and what you might call preventive maintenance. So if you're in an HVAC business, through technology, we can now increase your productivity by 2x. Pretty exciting. Now, what makes this work, of course, is that the more sensors we have, the better. And we call this sensor fusion, the ability to take multiple sensor inputs and synthesize what's going on in the system. This little example, here we have a blower motor that was running nicely. By the way, when the blower motor is running nicely, here's the way this is supposed to look. That thing comes up, runs for a little while, goes down, comes up, runs for a little while, and so on. Then what ends up happening, if it has low current, we see the exact same thing. It comes up, runs for a little while, and then comes down, runs for a little while. But if that current is lower, in other words, that average there is lower than the normal average, that shift here between those 2 numbers gives us a low current event. And if you then see that the differential air pressure here is also gone to 0, you can conclude that the thing that combines against that or across that, which is current from the blower motor together with actual airflow, is going to and not working the way it normally is. The only thing that connects those 2 is actually the fan belt. So in this case, we will then conclude, hey, the only reason this is occurring is that the belt is broken, and we will send you an alert. So now you actually, as a technician responsible for such a unit, you actually know exactly what's happening long before the occupant in the actual room below or in the offices below is affected. So that sort of early alerting and early alarming is actually something that gives you chance to react in a much better way. Just a little note on how is this actually working. Well, obviously on a rooftop, you may not just have one system, you may have several systems. And all of those systems are actually talking here to the cloud. So connectivity to the cloud, where all data gets recorded, and all data, all the machine learning is occurring, analytics are occurring, and any kind of state change, or like I just mentioned, a sensor fusion event is actually sent to dispatch and can also be sent to the actual the HVAC technician responsible for this particular unit. Or we can have it working in another way. Let me get rid of this real quick here. Boom, boom. Hang on. Let me get rid. I'm not good at getting rid of this stuff here. Let me try to get rid of it there. Come on, guy. There. there, and there. All right, so 2 seconds, boom, gone. All right, so let's take an example. Let's say this unit here sees something. It actually has seen an event. The event has actually gone to dispatch. Dispatch might actually go out and alert Joe, who's on this track here, who happens to be in the area. Go over and take a look. That's basically the model here. Now, Joe can also be alerted directly through the system. That's actually up to you to set that up. But the point being, we'll know exactly when something goes wrong on the roof at Joe's Bar and Grill long before Joe in his restaurant is negatively affected. And we can be en route to fix this problem the moment that something has been detected. So think about this, what it does to the average HVAC service technician and a classic PM business. Instead of coming out 4 times a year, being on the roof with all the gauges, which obviously is still valuable, but that's very, very expensive resource there. Having a technician send out with experience and be able to diagnose things, that takes time. And time is really what we're trying to optimize for here. We can then go from 4 PM visits per year to now go to, hey, we're there 24/7. What does that do to the customer? Hey, the customer for Joe's Bar and Grill, Joe in this case, will be very happy that this is occurring. He'll all things being equal, will get better service, will be on top of what's going on with every single unit in his chain of restaurants, and we can do that 24/7. When people are sleeping, we'll see if the system is running. So this is very, 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 very cool. In fact, what we're finding is when you just compare the amount of time that we're recording data for through intelligence relative to the way that it was done in the past, that's roughly 15,000 times more inspections. So imagine that. What would 15,000 times more inspections do to your customers? I think it's fair to say very likely it will increase the kind of stuff we can catch, and we can do a better job servicing the customer. A little graphic representation of what I was just talking about is actually this. Assume for a minute that we actually have a system running over here on this side here. It's actually running quite normally. And then we throw a fan belt here. Now, the subsystem will then, it won't necessarily start running abnormally. We've seen this, by the way, in the past where if there's a gas leak, the system's trying to make up for it, longer run times and the like. So we're seeing essentially that potentially we're in a deteriorating system mode here. So if you look at what typically happens in the old ways of doing things, where we have been sort of in a reactive mode, the customer will eventually find out that, hey, you know what? The air quality here at Joe's Bar and Grill is not particularly good. I'm not particularly happy. I'm calling up my service provider and complaining. And then scheduling gets involved and dispatch finds the resource, and it'll take time. It all takes time. So at that moment, what you get in terms of a customer experience, you get hours to days to fix. We've all seen this one. Hey, yeah, well, we just have a problem with the compressor. We don't have a compressor in stock. We need to order a compressor for the local warehouse. We got to go pick it up. We got to install it, only maybe to come out and find out that we are missing other things. Customers are coming back increasingly in this space saying, we want you to fix the problem quickly. We want to fix the problem right the first time. Well, many times the person that worked on the unit may not even be around anymore. Maybe this is an account that got inherited from your competition. You have no history. You have no way of knowing what you're getting into. So there's time being wasted. All the time the customer has what we might call unacceptable outcome. His restaurant is hot. His restaurant is losing customers. He's not a happy camper. So the model here then says, well, wait a minute. If you actually get early warning, if you know this long before Joe's Bar and Grill, you can actually detect, you can get an alert and use that detection to fix everything before the bad outcome occurs to the customer. So time is our enemy. And the earlier you know about a problem, the earlier it can be fixed. Don't wait for the customer to give you an angry phone call. It's no longer necessary, thanks to intelligence on the roof. What are some of the things we can detect for, you might ask? Well, this is a rather detailed list here, but let me just say, we can detect blower failure, dirty filter, cooling failure, compressor failure, blower fan belt failure. We also have a few more. We are detecting dormant system, in other words, a system that never runs, and its kissing cousin, which is a system that runs in the wrong time. So runtime detections we detect as well. All this happens automatically. Now, if you're looking at this from a customer's perspective, right, the end user's perspective, hey, if I don't have smart HVAC, I run things till they break. Here, we're now talking about predictive analytics, thanks to modern cloud computing and sensors, right? What's that impact to the business, you might ask? Well, it's quite significant, right? If I have people that are not enjoying being in my restaurant, they are going to leave. And if they leave, they can't spend money in my restaurant, my revenue goes down. It goes straight to the bottom line. Not only to mention that any erroneously running systems that are running in a suboptimal fashion, like, for example, running at night, that can turn out to thousands of dollars in a year. That needs to be found out and rectified. We actually had a restaurant in San Francisco that had a freezer that was running in a horrible state. Not only was the ice cream melting, but the freezer was running all the time. And we calculated based on the probably a little high San Francisco electricity rates, but we calculated that customer was spending an extra $3,000 a year just to keep his crappy refrigerator running in a very unsatisfactory manner. After we managed to come in and put Smart HVAC R on the system, which is a little bit more elaborate than the one we're talking about here, we actually managed to identify a bunch of problems, get them rectified, and save the customer 27% in cost over a year. That stuff actually has real impact. Your food is kept right, your comfort is there, and there is no loss of productivity or product. Now, if you look at outdated equipment, some of this stuff runs for a long time. You've inherited the lease if you're a customer, and the refrigeration systems and the HVAC has been there. But some of the stuff we saw that we just installed, the pictures I showed you, is actually that stuff is 30 years old. And it's still up there, and it's still running, and it's been running for a while. And you can see sometimes the screws are brand new because the old screws couldn't bite in the sheet metal anymore. So it's been stuff that looks like it's been through Desert Storm up there. It's actually interesting to see that even though industry analysts are saying that it's roughly a 20-year service life for an HVAC unit, some of them are running far longer than that. And by having inspection only of these older systems, that basically tells us we're not detecting anything unless we're happy to find it when we're out there, lucky to be breaking just the day we were there, or when the customer calls and complains. Here, you're basically replacing that vigilance with intelligence, and now you have automatic 24/7 monitoring and alerting like we talked about. Here's another thing too. If you are a Joe's Bar and Grill, right, that's actually worth highlighting here. If you're Joe's Bar and Grill and you have 10 of your restaurants in the greater metropolitan area, you have no way of seeing things across the sites unless you're working with a service organization that takes meticulous data and reports and comes and updates you every month. You have no way of knowing. Here we actually have a dashboard that shows every single unit across the entire population. So now you begin to do things like fleet management. Very important point. Fleet management has been a big thing out of the building automation systems, but now through this modern technology, it's accessible to the mid-market. So here you have full visibility across 5 rooftop units, across 10 restaurants, 50 systems, all being monitored. And when you see 50 systems as a herd, it's very easy to identify the ones that are not behaving like the rest of the HVAC units in the herd. Okay, finally, energy costs. We talked about that. Energy costs is probably the whole thing at the end of the day because it goes straight to the bottom line. If you save $3,000 a year on electricity, for example, on an average size company or small business, that's $3,000 that you don't have to spend. That goes straight to your profit. So obviously, that's why people are excited about electricity. I was recently in Australia. They have the highest energy rates over there. That was all they were talking about, green energy. And they talked about energy productivity. Ooh, interesting. Not just saving energy, but how much are you actually getting out of the energy you're expending? Very important point. So when you look at all this, there are 2 sides to this. If you're a service contractor and you're listening in today, hey, there's huge opportunities for you going to this intelligent approach. I mean, not only are you growing your business, you have a strong differentiator against the competition who's still doing things in the old school way. So that gives you a chance to grow market share. Because you're ahead of the problem as opposed to being behind the problem, you also give your customers a better experience. So they'll love you more. Basically, you have better sort of cohesion with the customer. Your customer now feels like, hey, man, since I signed up with you guys, this has been fantastic. And that's precisely it. This gives you that experiential differentiator. And that's been a big thing in the management literature lately, that everyone is essentially in an experience business, whether or not they're selling product or services. But especially the services, definitely experience. If you can give the customer a better experience, you have competitive advantage, right? Now, also, when you look at it from a pure operational standpoint, having your technician come out to the site, having a smartphone in his palm of his hand that tells him every single thing that's going on with that unit, gives him the history of the unit, something we probably need a separate little webinar for. But I'm telling you, having that power, that makes the technician an Einstein when he shows up. So there is reduced emergency scheduling because you don't have to send people out because the customer is upset. You are ahead of the game by going when you have resources in the area, which all things being equal means that you can have a better margins in your business. You use your resources better, and you also don't upset the customer by charging overtime left and right. So that gives you, overall, everybody wins, both the customer and yourself. Now, if you look at a customer, your customer, if you're an HVAC service provider, or if you're a restaurant owner or small office owner or manager that just dialing in for this or listening in for this, you actually get more knowledge. And there was a study done, I think roughly 17 years ago by Berkeley Labs that showed that there was huge advantages from an operator's perspective to know this stuff. You can do a much better job managing the experience for your tenants in your office building and so on, if you have that understanding. But what they said back then, and this is 17 years ago, was it was way too expensive. Well, here's the good news. This is no longer expensive. This is becoming much more doable for simply a couple of $100 a year. You now, for every unit, can actually have full understanding what's going on, which improves your operating costs because you don't have to spend money to the service provider for overtime and so on. And also, you reduce your energy costs, which sometimes cannot be just immediately rolled over into the lease of the tenant. That's actually, they actually buy the tenant, they have the lease inclusive of electricity. So they will use the HVAC system like crazy because it's not working well, and you end up getting stuck with the bill. Well, now you know what's going on, and you can reduce your energy costs. So there are lots more benefits here. Obviously, once you become knowledgeable of what's happening in things you're responsible for, it's hard to see why you would want to go back. So that's it. As quickly as I can do it, that's the new lifestyle of smart HVAC. Have a computer do the monitoring for you. Computers are very good at this. They don't ask for raises. They're not out on sick leave. They're there 24/7 on the roof, on the refrigerator, night and day. And the cloud sees everything, gathers everything, and you can do historical trends, and you can see precisely what's going on and what sometimes went on before something went wrong, which means you can do informed decisions, manage your business better, whether you're a service contractor or you're a restaurant or office owner. So that's pretty much it. So next time you're out driving your car, remember, this is about saving energy and making the world a better place. You grab a cup of coffee, just think about that. That cup of coffee can be almost had for free if you use OptumSoft products. So with that, thank you for your kind attention. I'm Denis Vilfort at OptumSoft.com. That's my email. If you want to engage with us and become a partner, please drop me a line or give me a phone call, and I'll be happy to meet with you and talk with you in more detail on how you move forward with Smart HVAC. So, Andrew, that's it for me. Do you have any questions while we've been talking here?
Thank you, Denis. We do have a few questions in the chat window. Just scrolling through it right now. Okay, so here we go. So first question, does this apply to both HVAC and refrigeration?
Great question. Thank you, Andrew. Yes, it does. There are different packages, different sensors. If you noticed, when I showed you the base package, it has a lot of extra ports. Those extra ports are used to connect to pressure sensors. So what we do is we can actually put line pressure sensors in. They're a little more costly than most of the sensors. So On a case-by-case basis, we would actually sit down with you and figure out precisely the right configuration. But we would normally put line pressure in so you can see the line pressures and line temperatures. So for purpose of refrigeration, we end up adding a few more sensors, and that allows us to see precisely what's going on. And we catch things such as short cycling. We can still catch that today. We catch things such as gas leaks, head pressure, all kinds of stuff that if you're in the HVAC R side of things, we'll find it very useful. Here's another thing too. People in the HVAC R system of things, like let's say again, a restaurant will have one walk-in freezer, one walk-in cooler, but they have 5 rooftop units. So they're actually more interested in having more in-depth knowledge because there could be $500,000 worth of product in there. And if the freezer goes south, there goes the product. And they have no choice but to throw away all the content of the freezer. So there are more loss involved there, and therefore a bigger reason to do a more nuanced monitoring. So the good news is the system is universal, and it works for both refrigeration and HVAC. And if you wanted to put one of these systems on pool equipment for purpose of monitoring when the pump motors go on, we could do that too. Again, this is a Internet of Things solution that is almost sometimes the challenge. It's a Swiss Army knife. You can do anything with it. So sometimes it's a little hard to just figure out where to focus. But yeah, it does HVAC and HVAC-R, both refrigeration and air conditioning.
And it's not limited to that too. This could work on any industrial commercial application. All right,
it cool. It could work on anything. You got it. You got it, Andrew.
All right, I got a question from John here. He says, all right, I'm a service technician in refrigeration. How does this technology affect me and my job?
Yeah, great question, John. Appreciate you asking. Here's the idea. I think it's fair to say that your ability to serve your customer is a function of whether or not you know exactly what's going on. Is that fair to say? And I'm sure you'd agree with that. That the more knowledge you have, the better you can serve your customer. So you know how in the past you had to be on the roof, haul your gauges up there. You had to sit there, put your meters on, finding out pressures, temperatures, current draw, all that stuff. And you could only really see that when you were on the roof. So it took you a while to drive to the customer in traffic. It took you a while to park your truck, get your ladder out, haul all that stuff up on the roof, get the sheet metal off the side of the unit and take a look, right? So that would take, an hour and a half, let's say. Now you don't have to do any of that. By having the system installed 24/7, if a customer calls or if you just want to see what's going on with one of your key customers, all you do is you whip out your smartphone, tablet, or your laptop, and you can see from there exactly the data being gathered and the historical trends of whether or not the system was behaving in the past as you would expect. So that's a thing, by the way, just by itself, okay? You will not be able to historically have had trends unless you had your own notebook that you meticulously filled out every time you've been there. Still, that would only give you data from when you were visiting. It wouldn't give you data when you're not visiting. And again, having more data. If you knew better, you would do better, right? So knowing more is the key. And what this system does is it gives you full historical behavior of across all the things that are being measured. And you can see correlations that are both negative and positive, whether the system is working or not. You can see whether it's working when it's supposed to, and also when it's not working when it's not supposed to. So you can see all those things, and that's without actually even leaving your truck or your office. So that's how it helps you. That's how it helps you. You have power of knowledge at your fingertips.
All right, we have another question here from Matt. So he asks, he's seen sensor kits before. How is this different?
If you say sensor kits, Matt, you're thinking about the very powerful but also expensive systems from like Johnson Controls and Schneider and so on. Yeah, they're depending on which one you look at. We probably don't have enough time to go into the full market landscape. But what historically has happened has been this: that Johnson Controls, for example, are very keen on selling you the sensors. That's not our model. Our model is this is software. It's the software that makes this work. The computers and the sensors have come down. I was talking to a service contractor recently in San Diego, and we were looking at the CT sensors, the ones that measure current. And he goes, "Oh, these are very expensive." I said, "Very expensive? I don't understand that, because we actually are buying these from China for $5 a piece." And I literally had to almost sweep him off the floor, because he fell out of his seat, realizing that. He goes, "Wow, that's not, we're used to paying $200 for these." And it's because we historically have seen an industry that's been focused on selling you the sensors. Well, we don't believe that's the right thing to do for the planet. We believe that sensors should be as low cost, or what people call near zero marginal cost. In other words, the cost is close to zero. So it becomes sort of a rounding error. And that's actually what we're seeing now, is that our sensor kit is very cost effective. And most costly part of the equation of getting it installed is the technician's 30 minutes of his time. It's less than that to actually buy the kit. So when you look at that, this is different because the hardware is through the floorboards in terms of cost. And the whole business model is turned upside down by basically this is a IoT as a service. That's what this is. So you're basically, just like you buy an Amazon membership or Netflix or anything like that. This is a service fee that's paid for us to keep the lights on, and for us to make a little bit of profit to run our company and pay our developers. And you basically leveraging cloud computing and the such. I was at the big show in Las Vegas earlier this spring, probably the biggest HVAC show on the planet. And it was interesting to see how everyone was sort of backing begrudgingly into this cloud thing. And depending on, everybody's like talking, saying, "Hey, we got to do cloud," but it was clear their systems were not ready for cloud. The differentiation here is this is built from the ground up by people who have like 20, 30 years of computer experience this is born in the cloud, essentially. So that's what's different, is that it's not the idea is new. Monitoring, we all agree, is a good idea. It just used to be too expensive in the past. So from that perspective, it's actually a much cheaper, much more cost-effective, I should say. We hear that most of these, I would say higher-end, maybe medium-sized office building management systems, they're easily $60,000, $100,000. And we don't understand that, because that's just basically putting it out of reach for too many people. And that's probably why the Department of Energy says that 60% of systems are running till it breaks, only because they can't afford to put the stuff on. So to cut a long story short there, Matt, is basically the whole notion here is, hey, we're putting it in at a price point where everybody needs to have this on their system. Everyone can afford it. Almost like, Henry Ford, right? Everyone with a good income should be able to afford one. Well, that's sort of what we're saying here. Everyone should be able to quickly see that this can benefit them. If I can save you $3,000 a year in just energy costs on an average size restaurant, yet I charge you maybe $500 all in, it's a no-brainer. So yeah, that's the big difference. It's not the idea is new, but thanks to modern technology and cloud computing, we can now do it cost effectively.
So how much does Smart HVAC cost?
Yeah, it depends a little bit of configuration. There's a startup cost, which is around $287 just to get the basic kit. And depending on if you sign up month to month, it's a depending on how many sensors, but let's say you have 5 sensors like the basic kit, that's $15 a month, okay? It's $3 per sensor, because all that takes space in the cloud and so on. And we're hosted on Amazon, and they want a little piece of the puzzle too, So the idea here is, yeah, you're basically paying for what you're needing. If you said, hey, we just want to be able to monitor one thing like temperature, yeah, I would say probably should reconsider that, because the more sensors you have, the better your sensor fusion, okay? So you need to have at least 2 sensors to do any sort of fusion. But if you say, no, I just want a single sensor system, well, that would be $3 a month, and it'll be $287 for the computer. And but yeah, most of our customers are actually doing anywhere between 5 and 10 sensors. So then the price gets a little more expensive. And if you sign up for a whole year, we'll give you 2 months free. So that's again, it all depends. If you buy by the drip, it's the month-to-month charge. You basically, we charge your credit card, or if you pay a year in advance, you're essentially buying a 12-month package. and then we knock 2 months off. So that should make it easy. So let's say you do that and you have 5 sensors. That's $15 a month, right? Times 10, because we give you 2 for free. It's $150 a year. That seems pretty. I mean, that's like what you pay for Microsoft Office, you know. So for that, having that to protect your refrigerator or your business is actually, we believe, a pretty good deal.
All right, we got another question here. So for HVAC and refrigeration, where do the energy efficiencies come from?
Yeah, it comes from the fact that most of the systems are not running optimally. If your system is running tip-top, let's say you just installed a brand new system and we got this harness of sensors on there and everything is looking perfect. That's exactly right. Everything is looking perfect until it isn't. In other words, everything looking perfect until something goes wrong, until something breaks down, until a fan belt is thrown or broken, or until someone walked by with a sharp instrument and accidentally nicked one of your refrigeration lines and gas is escaping. Bad things happen. And that's precisely why you have to have 24/7 monitoring. It, from that perspective, is a little bit like saying, why do you have a smoke detector in your house? Well, not because you're expecting to set the house on fire, I hope, but because you know, unless those smoke detectors are monitoring 24/7, the day you need it, the day your house is on fire, you got to get the cat, the dog, and the family out. That's when you actually need this thing to go off. That's why you need to check the batteries. That's why you need to have it up and running. So we're already very familiar with this. For this mechanism of alarming and alerting to function, you got to have a system on there all the time, right? And so that is the true benefit. So where does the power savings come from? If you see a system misbehaving, if you didn't fix it, let's say you have a system that you didn't catch because you weren't watching it, and it misbehaved for a year, and that cost you an additional, let's say, $5,000 to run because the system had lost gas by an accident. Someone nicked the line, and you're losing all the refrigerant. Yet you're not noticing because you're not paying attention. So it just runs and runs and runs, and your electricity bill goes up and up and up. So that's the whole point. Where do we save the money? We save the money because we compare to what should this system be doing and what is it doing. And 2 out of 3 systems are not running optimally. That's where the savings come from. And even if they are today, there's no guarantee that your system will run optimally tomorrow, which means, hey, it can be running fine today, but all of a sudden your gas mileage goes all to heck tomorrow. And if you don't monitor it every single day, 24/7, you wouldn't catch that. And then time, again, like I mentioned earlier, time becomes your enemy. Is that the more an undetected problem continue, the more it's costing you. So you want to catch that as soon as it happens. That's how the savings are being captured.
All right, we'll close it out with one last question here. When is Smart HVAC available?
It's available now in limited release. We haven't kicked it off 100%. We're still sort of in the early, I would say, late field tests right now. So if you wanna chat with us about this and become a partner, give us a call. Send me an email. Stay tuned, by the way. You can be on our mailing list too. We'd be happy to announce when we are launching this. We're planning to launch this, sort of take the covers off and make this available to everybody later this year. So when that happens, hey man, it's going to be a great launch event, and we're looking forward to it. So for now, if you want to get going today, just contact us here at OptumSoft, and we'll take it from there.
Great. All right. So that's all we have for Q&A right now. If you have any further questions, please reach out to Denis after this call concludes. All right. Thank you, Denis.
Thank you, Andrew. Pleasure. Take care.